Okay, can people see my screen for post for remote?
Yes.
Okay, great. All right, so today we're going to go into tuples, sets, dictionaries, classes, and move on to Panda series. And then on Thursday, we're going to talk more on pandas. So before I start, any questions, comments? So as before, please fire up your Python notebook on your command line, and we're going to go through those small snippets of code together. Reminder, you have submitted homework 1. Hopefully that gives you an initial assessment of where you are in terms of Python programming. Again, we're kind of giving you a crash course over some of those core Python programming techniques, but of course, this class is not by itself a complete Python programming class. So if you feel that the first homework is a bit challenging, I will highly recommend you to, first of all, refer to the resources we point out as Python tutorials. If you go to the webpage, under resources of the course webpage, you will see some of those online tutorials on Python programming. Another thing to help improve your coding skill is actually through practice. For each of those lectures, most all lectures, we have an exercise. Sometimes we have time to go through the group activity together with the exercise, but sometimes we wouldn't have time. For example, today, the content is quite vast, so I don't expect we will have too much time to go through the exercise among sort of groups, working groups. So I would highly recommend you to try to complete those exercises on your own. And if you encounter any issue, you can also come to office hours and pose questions over Piazza. Those are additional practice questions. Another reminder is, roughly speaking, we will have a homework like homework 1 due every week, pretty much. Because the first part of the semester is focusing on some foundations versus the second part of the semester is focused on the final project. So you will see a concentration of the homeworks coming your way. So as a reminder, this homework number 2 is going to due this Friday. Again, the late policy apply. You can have up to 2 days of late submission, but you lose 10% for each delay of those days. Okay. Any questions? Surviving so far? Okay, all right, let's get to it. So hopefully this is a big enough font. We are going to start by looking at a little bit over list comprehension. If you recall, homework 1 does contain a question over list comprehension. You can think about it a way, it's a compact way to modify or create a list in Python. And the syntax takes a little bit getting used to. So here is a syntax. You have square bracket, and then the first element can be a way to be an expression that kind of modify the elements, and then the second sort of almost like a for loop is accessing each element in the original list. So the new element could be a number or a sort of operation, and the original element as a variable is just a member of the original list, right? So sometimes you don't even need to specify this as a variable. You can replace it by an underscore. Okay, so if I were going to run this first one, what do you think I will get? This is sort of list of a range of 10. It will create a list that contains element from 0 to 9, okay? Now, this is where my list comprehension comes in, is that, well, I have my list right here, but I actually just want to modify it. My modification is for every single element in my list, I want to initialize it to be 0. So this kind of modify my list so that I just have a list of 10 zeros, okay? You can also, without doing sort of this list conversion, you can directly say for every single element in this range, which is from 0 to 9, I'm going to replace it by 0, okay? Now we are going to use the variable, so in all the previous one, I'm just using underscore because I don't want to specify a variable for it, which means I'm going to access every single element. In here, the next one is for every element in my list, original element in my list, I just have my original element. So what does this do? Go ahead. Yeah, exactly, right? I don't do anything, I just copied it. So that's what I have, right? So I have a copy of the list. Of course, this is a little bit boring. Instead of making a copy, I'm going to modify during the process. So this is this expression. So for every single element in my list, I'm going to multiply by 2. So if we do that, what I get is I basically turned all my numbers to the corresponding even number. Okay, so this operation here is really an expression that modify every single element. So this is a rather complicated one. As we go further, not only I want to access every element in my list, but I'm accessing it this way. So what does this mean? This is sort of the slicing operation, and this is sort of a little bit non-standard, getting a little bit used to. This is basically saying that I'm reversing my list, because this -1 is saying that I'm going through my every element, but my index is reversed. So again, I'm going through every single element in the reverse order, and I'm multiplying it by 2. So what do you think we're going to get? Yep, so it's going to be, if you compare to line output 5 versus output 6, it just reverse it. But the order is really that I first reverse each element in the list as I'm traversing it, and I'm multiplying by 2. So the traversing order is 9, 8, 7, 6, and so on, and I'm multiplying by 2. So now the next one, as we increasing the complexity, not only we can just do an expression, in this case, times 2, I can also apply a function to every single element. So in this particular case, my list, what is the length of my list? 10, right? So what do you suspect this is going to do? Exactly, it's because what it does is that it evaluates the length of my list, which is 10, and it's an integer. And then I'm going to just replace all my element in my list by this integer, okay? And finally, this is where we end up last class, is talking about random number generator. So if you actually import the random package, and then you kind of do .random, this particular thing that I highlighted generate a random number between 0 and 1. But of course, I want to be a little bit more complicated. So first of all, for any thing in my range between in 10, so this is sort of a list of numbers from 0 until 9. But now I'm going to do is that for each of those elements, I'm generating a random number, and I'm going to multiply it by 10. So all this operation is enclosed in one single very compact expression. And then this is assigned to be rand, which is now my new list. So if I do this, what this does is it actually takes a random number from 0 to 1, multiplied by 10, and then creating a list of 10 of those random numbers. Okay. All right. So that's what I want to say about list comprehension. And today we're going to cover several more advanced data structure in Python. And then they have sort of advantages and disadvantages, depends on how you want to use them. Any questions so far? And for people who are remote, feel free to unmute yourself and ask questions too. Okay, so the first thing we're going to go over today is called tuples. So they are list-like things, but they are immutable. What I mean by immutable, that means you cannot change those items once you created them. So in a way that you cannot reassign elements in there. And tuples are intentionally designed to store objects of different types, okay? So if we recall our list, what we learned last time, whenever we use a list, the convention is to have sort of homogeneous data set. And then especially if you're using NumPy lists, that will actually enforce that. But then tuples are designed for what's called heterogeneous, which means you can mix kind of the types of the data. And they're really, really used in what's called a hash table, which is a way to kind of indexing my data set or store my data set, effectively retrieve my data set, which we're going to discuss today. So now, first of all, I'm going to create a tuple. And then there's two types of syntax. The first type of syntax is I just provide essentially a collection of things. For example, this course was originally created by Alex Lex. So he's using his birthday, speak of privacy. So I create a person whose name is Alex, whose birth year is 1981, whose background is in computer science. So if I do that, it's going to return this thing, which is enclosed by round parentheses. It basically says, I now have a tuple that stores 3 pieces of information, the name, the year, and then the major or the background, okay? But of course, you know, if you want to be explicit that I'm creating a tuple, then what I need to do is to just put parentheses. And then this have the exactly same effect. You know, it's just a personal preference whether you want the parentheses or not. Now you can access this tuple just like arrays. So because this has 3 items, if I'm asking person, you know, index this particular object, this tuple with index 1, what would it return? 1981, right? Because remember, index start from 0. So this is 1981. What about if I do this? Australia. Because remember, the last person that I created here has 3 different things that is stored: the name, the year, and the country Alice is from. And if you're thinking about indexing, it goes index 0 is going to be Alex, and index 1 is 1981, and index 2 is Australia. So you can access it as using those indices. So for that matter, is very much like a list, okay? However, here's a difference between a tuple and a list, because remember, it's immutable, meaning that you can't really reassign values into it. So if I do person-1, what you're going to get is going to have an arrow, right? It's going to say, this is a tuple object and it does not support item assignment. This is really means that because this object is immutable. Now, you can also create tuples with arbitrary object, not just, you know, strings and integers of those basic data types. In here, what I can create is, again, I'm creating a tuple. I'm emphasizing it's a tuple by the parentheses. But this tuple contains 2 objects. The first object is a string, say it's a string 1. The second object can be some list by itself. So if this is the case, right? Now I have created this tuple, and I can access each of those elements. But in addition, I can access this element in terms of treating the second element as a list and then accessing the list. So once it's a list, you can actually change reassign list. So what is happening here? If I run this, first of all, let's actually just do train schedule, just to see what is in the train schedule first. Did I do? Oh, I just did. So initially my train schedule is 7-11. But now, remember, even though the tuple itself is not mutable, but the list as an element of the tuple can be reassigned. So in this particular case, it says the first element, actually, this is what I actually want to do. Let's see. Let's see if I can rerun this. Let's see, so. Oh, of course, now I have to rerun everything. Just a second. If I do that. Okay, so if I let's do this. Okay. So this is what I want to do first, is to say I can access the first element, index 1 of my tuple, and that is a list. Then I can modify this list. So that the first, the zeroth element of this list is modified. Okay, so the fine difference is you can't directly modify a tuple element, but if the tuple element is something by itself mutable, then you can update it. Okay. So now if I disable it, right? So actually, if I do this, this is going to create error. Why? There's a fine like syntax differences between this line and this line. Have you noticed the difference? Yeah, what is it?
The second element is the parentheses and the square brackets, and so the tuple is immutable.
Exactly, right? So previously, the second element is a list. It's mutable, so you can do assignment, versus now I created a tuple whose first element indexed by 1 is also a tuple, so you cannot modify it. All right. Okay, so now you can also work with tuple in the sort of function itself. So in this particular case, I have a function that multiplies 3 numbers, A, B, and C. But what it returns, it actually returns a tuple that contains 4 elements. It returns A times B, A times C, B times C, and A times B times C. And when I execute this, of course, well, no, I haven't executed. If I execute it by providing 3 integers, what I get is a tuple that has 4 elements. The first 21 is the first element times the second element. Of course, 33 is the first times the third. And then, you know, so A is equal to 3, B is equal to 7, C is equal to 11. And I return a tuple that contains their multiplication. Okay. Now let's go a little bit further. You can, in fact, remember this function returns a tuple, right? It returns a tuple of 4 elements. I can assign what is returned, this particular tuple, back to a variable, and I can print it out. So this particular case, what I do is to say, okay, I am assigning AB, AC, BC, ABC. Now those are variable names. As a result of multiply those 3 numbers, 3, 7, 11, and I can print my tuple to be exactly what the function returns. Okay, so in a way that, again, this is a fairly sort of compact code that your function returns a tuple. I can take each element of the tuple and assign it to a variable. So for example, in this particular syntax right here, I'm basically saying that, okay, AB as a variable, that is going to take the value of, you know, 3 and 7. So let's do this. Let me just print this for the time being. Right? So the AB is a variable, but this does not throw a error if I were going to reassign 19 to AB. Why? I mean, AB, I can update the value. So Because AP is just a variable. It just stores an integer in this particular case. It's not a tuple. Okay. Now, you can, with tuple, you can also do assignment that is very, very compact. So what does this mean? This means on the right-hand side, I have created a tuple that has 4 elements. And for each of those corresponding elements, I'm going to assign it to a variable, which is called what is going on. So if I actually do this, right, this is printing this 4 variable, which each variable get one of those string as its value. Okay. All right. So we'll see tuple later in hash tables. And before we move on, let's talk about some sort of data structure that is more similar to a list, but it's unordered. And this is called sets. And its behavior is very similar to the mathematical definition of a set. There's 2 nice properties about set. One, it's not ordered, right? So if I said I have a set of an apple and a banana and a peach, it's the same thing to be a set of a peach and a banana and an apple. The ordering does not matter. That's number 1. Number 2, it cannot contain the same element twice. So if I say I have a set that contains number 2, 2, 3, 4, the 2 is going to be eliminated as my set object. So if I do the set conversion, it's actually eliminate duplicate copies. Okay. So here is an example, of course, going back to singers. In this case, the set notation is a curly bracket. So if I use curly bracket, that means I'm just creating a set. And then this is a set with 4 names. Now, remember the set can also be initialized by a tuple. So the difference between the first line 37 and the next line 37 is directly initialize the set by specifies element using curly bracket. But also what I can do is I can say, well, I have a tuple that has 4 objects, which happen to have 2 copies of John, but I'm going to convert it to a set. So what's going to happen if I run this line? Sorry, say it again. It's going to eliminate a copy of John, right? Because it says, now I want a set object. There's 2 duplicates from my tuple. I'm going to get rid of it. Okay. So in this particular case now, you can also, one of the interesting things with set is you can say whether a particular element is in the set. Remember, my username now has Jimmy, John, and Robert. So if I say Jimmy in username, which is basically saying that does my set contain this element? The answer is true because my set contains Jimmy. But if I do is Ringo in the user name, the answer is false because it does not contain it. So in a way, there is a pretty fast access to check whether my set contains a certain element. Okay? Yes, go ahead.
So when you're working with a set, you can't do like the thing where you find index, right? Because it's not ordered.
Exactly. We're getting to that very soon. You're maybe like a minute ahead of me. Yeah. So this is exactly how you do. So now if you have, okay, a little bit detour. We have a set and we can use if an element is in the set and it's going to return you true or false to tell you whether it's in there. But of course, the same type of operation can be done with list. So for example, now this is a username list with sort of square bracket. And then I can also do is John in this list. The difference between these two is that though it's achieving the same result, that searching through a list is more costly. Okay, so in a way that if you're thinking about in this particular case, my list is tiny, so it doesn't, the performance, you don't see a performance difference. But if you have a really, really large collection of object and your goal is to try to figure out if it contains certain object, then using the set is significantly faster than using the list. But of course, the drawback is that the set, you cannot use indexing to access it because there's no ordering. Okay. But also as a set, which is sort of like a bag of object, you can add stuff to it. So in this case, remember my user has 3 things in there. I can do add. So if I do the set dot add, right, the set variable name dot add, I'm just adding an extra thing to the list. But I can also remove from it. So for example, in this list, I'm going to remove John. So I have removed it. But here is a problem. If I directly remove something that is not in the list, in the set, you're going to get an error because it says key error, meaning that I don't have this object that essentially mapped to the key Joseph. So this is again sort of a bad programming practice where you try to directly remove an element. In order to be more careful, what you do is you put an if statement to say if this element is in the set, then I'm going to remove it, right? To kind of get rid of this kind of error. So what you do is to first check whether the set contains the element. So you just say if statement, if Joseph is in my set, then I remove it. Then of course, there's nothing, Joseph is not in there, so nothing is going to happen. You prevent the potential error in your code. Now the same thing as list with set, except remember list, you can access lists through indexing, like what you're asking from 0, 1 to 3, you can access it. But the way you're accessing a set is just enumerate all the elements. So for example, this current line is for every single element in my set, print it out. Okay, yeah.
Is the in thing you did just sound like that for name and username, is it case sensitive? Does it matter?
Oh, let's try it, right? Let's do something that in the set. So let's do Jimmy, right? So let's do remove Jimmy. And I kind of want to print username. Okay, so did I spell something wrong? Usernames, huh? Yes. Okay, so let's remove it as what it should be. Now let's do, what else is left? John B, right? This is a lowercase. It's not going to remove it because the uppercase and lowercase are not the same string. Okay. But of course, remember, this might be something practical you want to think about, especially when later on when you're doing data wrangling. If somebody accidentally enter their first name with a lowercase, it's still the same person. So you might want to do some sort of conversion, right, when you're removing duplicates. Okay. All right, let's move on. So now we know list, we know set. The next thing we're going to move on to is called dictionary. And dictionary is quite more powerful than the set. And what's really, really important for dictionary is it stores something called key value pair. So what is the best sort of example to kind of imagine what is a key value pair? If you think about phone book, I don't know, how many of you actually even see a classic phone book, they throw it to your driveway, right? So in that case, what is sort of the key? It can be, say, whose name associated with a phone number. You can think about the name as a key and then the phone number as a payload. Or you can say, here's an address, which is a key, and then there's a corresponding phone number. Another example is a dictionary is, for example, if you think about your student record, each one of you has a student ID. You can think about the student ID as sort of the key and your name as a value, right? So key value pair is in a way of trying to access, a particular, the value is what I call payload. You're trying to access your payload through that key. So let's just see if give an example. So I am going to create a dictionary. Again, the syntax is curly bracket, except that because remember I say it's a pair, so I have the key value pair. In this particular case, the first column that you see here are the key, and the second column are the value. And notice that you can have sort of different keys, but you can have the same payload, right? So in this particular case, I have John as a key and Zeppelin as a payload, or the value, Jimmy as a key, and also Zeppelin as a payload, where, in this particular case, I'm just saying that, okay, John is part of Zeppelin and Paul is part of Beatles and so on, okay? So again, it's a curly bracket, and the syntax is there is a comma that you are using. Now you can also specify the dictionary by using sort of the dictionary keyword here and converting a particular list of list. So in this case, remember now I have square bracket, which means I'm creating a list, and the list is a list of 2 tuples, right? The first tuple is Tom and Radiohead. The second tuple is Dave and Foo Fighters. So this tuple basically indicates that the first item is going to be my key, the second item is going to be my value, and then this keyword here is converting it to a dictionary. So if I do that, it's going to return a dictionary, meaning that the first is a key, comma, value, key, comma, value. Now, the dictionary's key and value can be of any type. So this is example as where 3, 4, 19, 6 are my key. And then the payload or the values are sort of floating number. So even though I said that the key can be any value, one thing to avoid is to avoid using float as keys. Any guess why that is the case? Like why we shouldn't use a floating number as a key? Anyone? Remember we said at the previous class, 0.1 plus 0.1 plus 0.1 sometimes is not equal to 0.3, right? Because sometimes when you specify floating number as a key, you actually have no idea how that floating number is really stored. So when you go back later on, want to access that item using the key 0.1, you might not find it because the floating number is not stored as what you think it is, right? So you might not match to the same key. So the typical practice is using integer or string as key, okay? Now, the next thing you can do is create more complicated dictionary. And then this is pretty common. For example, if I say your key is your student ID, but your student record is not just your name, but maybe your address, maybe your email addresses and your, I don't know, even GPA and so on and so forth. Those are sort of large record that could be kept in a dictionary. So again, in this particular example, I'm creating key, which is a name. And then the dictionary, the value associated with this key is now a list. And it's a band that I guess this particular person's name has showed up. For example, Dave has been part of Nirvana and Foo Fighter, Eric has been part of Yardbirds and so on and so forth. So if I actually print it out, it's now a dictionary where the key are the names and the values are list of bands. Okay, so you can create sort of quite complicated dictionaries using this kind of syntax. Now, the interesting about dictionary, it works almost like a list because in this particular case, we can pass on the sort of indexing, but in the list, the indexing goes from 0, 1, 2, 3. In this particular case, you can obtain an item by actually looking at the key. So if you recall, numbers has keys that is 3, 4, 19, and 6. So I can access number 3. Remember, the 3 is not an integer from 0 to like whatever number. This 3 is actually used as a key. So what is going to be number 3? Anyone? 1.45, because that is a key. Same thing with, the multi-band musician. If I do Eric, what it will return? Yes, it's going to return a list. Okay. Now you can, of course, add more elements to a dictionary by specifying its key and its value. So this particular case, I just added an extra key value pair where the key is Tom and then the value is Radiohead. Okay. And then you can, of course, remove. You can delete using DEL. You can remove a particular entry in my dictionary whose key is Tom. So there's actually multiple things that goes on here. First of all, it's going to search to see whether it has a entry whose key is Tom. If you find it, you remove it. So again, there is an arrow. If I already removed it, in this case, if I try to remove it again, it's going to return an error. So this is a similar scenario in the previous situation when you're dealing with sets. If you want to remove an element, if you want to be careful, your code have to check whether it's in there or not, and whether it's a valid key that I'm trying to use to access my data, okay? So in this case, if I do musician.keys, it's going to return the keys associated with this dictionary. And then what you can do is you can use this key, right? So remember now, this is really a returns all the keys from my dictionary, and for each of those keys, I'm going to print it out. Okay. So now, what dictionary as an object is a more sort of involved data structure that you can access the list of keys in there, and then using the keys to access the corresponding elements. So how do you access the corresponding elements? Remember, it's a key value pair. I can return the dictionary.keys. I can also return dictionary.values. So in this particular case, there is a bunch of values associated with my key. And finally, you can also access the items. When you access the item, it basically returns you all the key value pair. Okay. So now, same thing as before, when you have a list, you can iterate through all elements in the list. When you have a dictionary, you can access sort of the key value pair from my dictionary. So in this case, my syntax, again, it's a fairly compact syntax. It's for every key value in the item, I'm going to print it out. So in this particular case, it's going to return John as a key, Zeppelin as a value, and then it's going to add a string in between, which is the band. Okay. Any questions so far? Okay. And then finally, the same iteration can be rewritten by just going through the keys. So I can say, well, for every single key, I'm going to print the key combined with the string band and the corresponding value associated with this key. Remember, whenever we do dictionary with a key string, it's going to return the corresponding value. So line 63 and line 64 returns exactly the same type of results. It's just a slightly different syntax. Okay. All right. So I guess I'm going to give everybody a 5 minutes break. We're going to come back at 4:24. Okay. And do I have any questions remote? I don't see any question. Good. All right, so there's a question. The first comment in the first code block of object-oriented programming does not sound correct, at least the wording. It sounds like it's saying person.name is a static among instances of the class. Okay, let me go over that. Okay, first comments. Okay, so you are talking about, and feel free to correct me if I misunderstood your question. You are talking about these comments, right? Yes, so this is a particular variable related to, if I create a person, let's say Alex is a person, Bei is a person, each one of them is going to have alex.name and bei.name. And then they are sort of variables associated with that particular object. Does that clarify your question? Yeah, so the wording, a class variable, yeah, when this is shared by all instances, is to say that, in some sense, maybe you can say all instances will have access, well, each instance will access this, will have a copy of this particular variable. Does that make sense? Yep, okay. All right, let's move on to object-oriented programming. Of course, there is existing classes that is just on object-oriented programming. So we are going to just talk very high level. And in fact, we were not doing much of object programming in this particular class, but we are frequently going to use object returned by library. So it's really important to understand some fundamentals surrounding object oriented programming. So the idea is that you can create those classes that bundle together multiple facets of the data, right? And then those objects or those classes is a combination of data structure and functions. And then the function inside each of the class is called methods that operate on the data associated with the object. To make it very precise, I can define a class called a person, and then I can initiate multiple instances of a person, okay? So let's look at this first example. If I were going to talk about a particular person, the type of information associated with a person is, of course, name. So in this particular case, think about the class as a template for creating a particular object that is a person, and it has associated data structure. In this case, it's associated name variable that you can assign a name with, okay? So now there is a little bit syntax that we have to pay attention to right here. The first is, well, each class is going to have a variable associated with it that's called name that you can assign values to. But if I don't do anything, I'm going to use what's called the default name. And by default, I'm going to say, name is blank, okay? But now what's really interesting is you can actually looking at functions that assign names to a particular instance. In this particular case, the syntax is very specific. Inside the class, whenever I want to assign the variable name, I need to first specify self, meaning that I'm referring to the current object. And for the current object, its name is going to be my input name, okay? And then I can also define other functions that kind of operate, or method that operate on this particular instance. For example, again, it takes self, which is this particular class, and it's going to print this corresponding name. Okay, so let's see what we can do. Yep, go ahead.
So where is like self set as the word that you use? Is that
Yes.
common, or is that like in the underlined init thing, or like?
Oh yeah, we're going to come back to initialization soon, but let's first of all ignore this for now. This is initialization. This is actually the default initialization. But for the time being, I want to give you an example of creating a person and assign the name. Hopefully that will address your question. Okay. Oh, wait, I don't want to execute this. Why did I execute this? What did I do? Let's see here. That's not good. Let me. Why did I type something weird here?
I think does everything need to be indented after the def itself?
Yes, like here. I think I did some. So this is one thing that bothers me about Python is indentation. I don't know what I did in terms of typing. Did I do something weird? All right, let me restart. Let me just make sure I'm grabbing the latest version. Okay.
Set name and predictor to be inside the index.
What's that?
To set name and predictor to be inside the index.
Yeah, I did that and it worked.
Yeah, we'll just have to indent.
What did I do? Yeah, let's see if I think I might have typed in something while I was, my,
Well, you just did it,
oh,
Just that B needs to be indented and then self-name needs to be indented
and then same with.
and then same with the bottom one.
here?
So
Like,
just
all of them.
all of them have to
all
be
four of
just
those ones.
indented one
You
time.
just need something.
After-
I think I did indent.
Like
But it
one
has to
plus
be
one
easier
under
to-
it.
Bay, you may want to type in pass in the init function.
Sorry, go ahead.
You may want to type pass here. Yes, pass.
Did I do? Did I don't think I modified. Maybe I did something. Let's see. Oh, perfect. Okay, so it saved the same thing. I'm not doing anything. Okay, cool. So I can do this. So if you actually look at line 3 right now, what I did is, first of all, ignore the person. Oh, I created 2 separate classes. There's a class called person. There's a class called person2. Those are 2 different classes. And then the first class has one single variable called blank, like name, and its default value is blank. The second class has 2 variables, one is a name and one is hobby. So if I create a new person, which is a variable, I create it as a type, like a person2 class. What it does, and if I don't provide any value right here, it's going to take the default value. And now if I take the default value, I can reassign the name to be Robert, and I can also reassign its hobby as swimming. So if I actually do, I can do print name, okay? So what I created is I create a default person who originally, actually, let's even do this. If I don't do assignment, the originally its name is the default value, its hobby is default value, which is blank and blank. But then if I do reassignment, I can reassign the value to be Robert and the hobby to be swim. So in a way that what I have done in this particular line is creating an instance of person2. Then I can operate with this instance. Okay. Now, let me go back to the first class object, which is person. So again, if I declare someone whose variable name is Ringo to be a person, I can print its name. And because if you look at the person class, the default name is blank. So if I actually print it, it's going to first print the value to be blank. However, one of the interesting thing about class, think about a class as a container of a bunch of methods that can operate on its data. You can actually use the method called setName. Remember, I have a method in here, setName, is to say if I provide, so this is where the little subtlety you have to be careful. Even though in your class definition, your method specify 2 variables, one is self, one is name. When you're actually calling it, you actually only provide the variable name. The self is just a reference to this particular instance. So in this particular case, what you see here is you have set name to be Ringo. So the Ringo is a name you want to replace the variable name with. So if I print it, it's going to print the name to be Ringo. So that's what you get. So again, let's look at how this function is called. You initialize an instance, which is a person, and then you call the method associated with this instance to set its internal variable name to be Ringo by calling the method right here. And once you have done that, you have essentially assigned a value to this instance name, okay? Okay, now this is a notation you're going to use quite a bit. Is in order to access the method associated with a particular object instance, you're just going to call the variable which represent that particular object. In this case, this is a variable that represents that person. and you use the dot and then the function name or the method name. And that's how you access this particular method that is in some sense enclosed in the container. So think about a class as contains a bunch of variables that stores the data and a bunch of methods that can operate on those data, okay? So let's create a different person, right? So whenever I said, I created a person called Ringo, this is an instance of a person. Now I create another instance, which is called Paul. This is another instance of a person. So for this second instance, the Paul instance also has its name and it has method that can operate on the name. So in this particular case, I'm going to set the name to be Paul. And this is the two lines you want to pay attention to. Remember, I have a Ringo instance and a Paul instance. Each one of them is going to have its own name. So if I print the Paul.print name, which is a method associated with the Paul instance, it's going to print the name associated with the Paul instance versus the Ringo.print name is going to print the name associated with the Ringo instance. So this goes back to one of those initial questions online. Is this variable shared across instances? No, because this variable is attached to each of the individual instance. And you access those variables by using the dot. And you also access the method by using the dot, okay? Now, if we actually look at the type of Ringo, it's going to tell you it's one of those complicated objects called a person class, okay? Now, let's go back to initialization. So everything I have talked about so far is to say I have methods that I can access my data by assign names. But sometimes if I don't provide anything, I want to have an initialization. And that's what this $_init__ is meant for. It's sometimes called a constructor. It's essentially a method that is called by default to initialize the object. So if you actually look at the syntax of it, in this particular case, I create a new class called musician. And then the musician contains 3 different types of properties or data. One is its name, one is the instrument it plays. And then the last one is sort of like a combination of those two, okay? So the initialization is going to initialize a particular instance by the name and instruments you provide, okay? So, and then this class have another method to just print information associated with an instance, okay? So now in this particular case, I can initialize a musician instance of a musician class by providing 2 variables. Those 2 variables are directly called into the initialization function by assigning it to be the name and instrument. So once this is called, if I print musician, it's going to since it has already initialized the name and the instrument, it's just going to print the information that is initialized with. So, oops, actually I need to execute this first. And then in this case, what you get is it's going to access the first variable, which is name, and it's initialized with Ringo. It's going to access another variable called instrument, and it's initialized with drum. Okay. Any questions so far? So the way, of course, this is such a crash course. There's many sort of nuances associated with doing object-oriented programming, but I think the main takeaway you want to think about is a class is essentially a container that contains data and a method to access those data. And when you initialize an instance with a class, you kind of inherit some of those properties associated with the class. So you get multiple instances that are by themselves pretty complicated objects that you can play with, okay? And you can, of course, access, like I said, you can use the dot to access individual variable. So for example, Ringo is a musician. So if I do dot instrument, I'm accessing the variable attached to Ringo. So the one place you have to be careful, if you already have initialization constructor like here that requires input and you don't provide the input, for example, in this case, it's asking for 2 input. And in this way, you are not providing it, it's going to give you a type error, okay? So a work around it is very similar to what we have seen before. When we're constructing a function, you can provide default values. If you provide default value, if you don't provide that parameter, it's going to take the default value. So same thing as before, if you look at this particular syntax here, this is saying that, well, the default value for name is going to be my name. The default instrument is going to be called default. And there's also a third variable here is whether there's a backup singer or not, and that default value is false. So if you do that, it's going to, if I create a poll, which is a musician, by providing the name, the instrument, and if it does not provide whether it's a backup singer, it's going to take whatever default value it is. And in this particular case, if I execute this, this is going to print out its name and the instrument as before. So this would not throw an arrow. In fact, we can, let's see if I work it more. I don't think I use this again, so I can modify this. So if I actually do this, because I provided all default values, okay. What did I do? Musician. It's still asking. I want to do this. Let's see.
Bei, you may want to rerun the previous.
Yeah, I just rerun it. Yep, you're right. So yeah, so in this particular case, what I have done is I said, I'm only going to assign the name Paul to the variable name, but then the rest of it, I'm just going to use default value. It's not going to throw exception. Again, let me go back to what I want to do earlier. Need to rerun this. If I just initialize it without specifying anything, it's going to take the default value. So the default value of name is my name. The default value of instrument is called default. Okay. All right. Thanks, Minzhe. Now, in a lot of scenarios, when we are actually working with Python code later in the semester, we're working with modules. So for example, there's a very common module called math. So it comes with all the methods you can operate with math with. And again, whenever you import a module, you can take the module name, okay? And then you can just use dot to access its interior function. So for example, the common math module, I can import it and I can take the square root function that is pre-encoded for you. But specifically, whenever you import a module and all the functions from the module, you might not need to use all of them. So sometimes, for example, you only want to use sort of the logarithmic operation. So you can import from the math module, you only import this particular function. And in this case, this is just take the log. Right? So the difference is when you actually use the syntax from math import log10, when you access this particular method, you no longer need to provide the module's name. Okay. So you can also say, well, I just want to import everything from that module. So I can do from math import star. And then in that case, I'm just taking all the existing math operations that is part of the module math, and I can do the operation. But this is highly discouraged because sometimes when you import everything from an existing module, you might actually run into name clashes because you might have your own code that does square root, right? So if you import another package or another module that contains another square root operation, that identical name, you're going to have a name clash. So the recommendation is you only import the ones that you need to use, or you specify as a first option here, you specify the specific function you want to use, but specify the module name so that there's no clashes. So in case you have your own SQRT implementation, they're not going to be a clash because you can use yours directly without specify the module name. But of course, it's also more recommended if you have your own sort of operation. And then if you have a collection of them that is all performing certain operation, you can package them into a module as well. But that's a little bit too much for today. Finally, we're going to talk about series. And then this is going to set up what we need to do on Thursday, which is sort of data frame. Oh, one last thing. You can also simplify the name of the module if you are too lazy to type in case that module is really long. So you can say, I'm going to import math as M. So M is now just replacing the name math. So you can do m.sqrt, which is the same as math.sqrt. You just simplify the name of, it's a shorthand for the particular library you're using. Okay, so what we're setting up for Thursday is dealing with ways to manipulate vectors and tables and time series. And then this is going to rely on the library called pandas. And then there's a lot of different things associated with Panda, but what you are doing here is you are going to import Panda as a module and then using a shorthand. And now what's happening is that you can initialize series within pandas. Okay, so what does this mean? So if I do, so this actually looks very similar to a dictionary. Is that I have, first of all, I have created a list, okay? And I'm converting this list into what's called a panda series by doing pd.series. So pd is a shorthand for pandas, and I'm converting it to a series. So what is this, okay? So this is very much like a column representation of a list. So what is associated with it is you have this sort of default index goes from 0, 1, 2, 3, and then value associated with the index that is Stones, Beatles, Zeppelins, and Pink Floyd. Okay, so in a way that this is very much like a list, it's behave like a list where you can access it. And similarly, you can create, of course, Panda series using sort of strings. You can create Panda series using numbers. So if I create years, then this is a sort of a series. And then the data type is telling me for each of the values that is stored here, this is int 64. So again, this is very similar to the behavior of NumPy. When you start manipulating integers in NumPy, the default integer type is 64 byte. Okay. So in a way, when you look at the series, it's very, very close to a list. But you can also think about it as axis or a column of your data. So again, your index 0 is associated with the value Stone, index 1 associated with value Beetle, 2 associated with Zeppelin, and 3 and so on. So, and each of those values is sort of an object type, okay? And in this particular case, this is sort of a string, and in the previous case, this is integer. But the difference is that if I don't specify the index as integers, I can specify index as strings. So this part is very similar to the behavior of a tuple. So again, the first part, when I initialize a series, the first thing is a list, which is my payload. And then this particular payload are the years. Now, the second line I'm showing here is to say, what is the corresponding index I want to use? In this case, instead of using integer index, I'm going to use string as my index. So this is very similar to a tuple behavior. So in some sense, think about this as my key. And then this is going to access this is a zeros key, this is a zeros payload, this is the first key, this is the first payload, and so on. And finally, you can assign the series with a particular name. So if I actually do this, what you have created is, again, think about this almost like a table, where the first column of the table is my index and the second column is my payload. So in this case, my first columns are, my string-based index, and the second column are the year. The important thing here is actually, and this is very unique to series, you can see that I actually have two identical index, Pink Floyd, but they have different payload, okay? And this creates some interesting operation you can do with the series. For example, in this case, if I have initialized my, again, thinking about this is one way to store my data. I have an index column and I have a value column. So if I actually access the bands.value, it's going to access the second column in my table. Versus if I do bands.index, it's going to, oh yeah, this is just to say, well, the index goes from, there is multiple values in there, okay? But if you want to use, oh yes, the difference between bands.index versus bands.founded.index is the second one actually accesses the actual column, versus the first one just tell you the range of the index, how it's composed. You can also access it using sort of treat it almost like an array. So if I say bands 0, it's going to say, well, even though my specified index is sort of the string-based index, but really the first item is a zeros item, which is 1962. Right? Oh, sorry, no, which one am I? I'm doing bands, so this is not. Is this bands? Yes, so I'm actually accessing the zeros index, not the zeros value. But if I want to access the value, I can provide the index and it will give you the value. So in this particular case, right here, if I provide the key, it's going to give me the value. So all the behavior you're seeing so far is very similar to the tuple behavior. Right, you can provide the key and it will give you the value. And finally, you can look up, for example, if I provide a key, it's going to say, well, what is the value associated with this key? And if you provide a list of keys, it's going to return you a list of values. So one way to think about the Panda series, it's a data structure that stores information like a table, and you're accessing the entries on the table. If you provide multiple keys, it's going to give you multiple values. And remember I said, you can actually have multiple keys of the same value of Pink Floyd. So if I actually ask, give me all the value associated with the key Pink Floyd, it's actually going to return 2 entries. So in a way that the Panda series, think about, again, is a storage that store your table, and you have access to the information in this table, and you can manipulate them. And that's what the power of the series is. Okay. Now, next thing I want to cover is there is a way to access the actual locations of a particular key. So in this particular case, we are going to find, the location associated with the key stones and return the value associated with that key. Okay, so that's another way to access it. And then there's also an iLocation indexer, and then that's a little bit specific. That's purely based on location. So remember, if our location start from 0, if I provide 1, it's going to return the second row of the value associated with the second row of my table. So if I do the I location, it's going to be 9060, 9060, right? Which is exactly the second row. So think about the series as a way to store your data in a table. And in this particular case, it has a key value pair and you're accessing the first column or versus the second column with the location variable. You can still do iteration. And again, for this, it's very similar to a list. You can say, well, I have the series called bands. And for each one of them, I'm going to print the value of it. And then the second part here is I'm going to print both the index as well as the value. Of course, I need to do a little bit typecasting because I'm concatenating all this as strings. So what this does is that the band is the key, the founded is a value. So again, I'm accessing key value pairs in my series. You can also update, right? So again, you can actually change the value. So in this particular case, if I change the value attached to index 2, which is this particular row, so I'm replacing the value associated with that row. So this is again mutable. Okay. You can add. In this particular case, I'm saying that I'm going to add a new entry where the the key is 4 or index is 4, and then the value is Zeppelin. So you kind of added an extra thing. The interesting thing is that remember the index, even though right now I'm using integer as index, it doesn't have to be continuous. So for example, I can add another entry whose key is 17 and whose value is the who. So in this case, I'm just basically think about this as appending to my table. I'm just adding another row to my table. Okay. The interesting thing about updating the value with the key, if you have multiple entries with the same key, then if I do an updating operation, it's going to update all those entries. Okay. So the reason I'm going through this is that even though the series is a very powerful data structure, you have to understand the consequence of your operations, especially when they're duplicated keys. Okay. And of course, you can also use iloc to try to figure out the corresponding, to try to find out the corresponding entry and then update to the corresponding value. So in this particular case, you're saying that, okay, I am going to look at row 3, which is 1, 2, 3. It's a 4th row, and I'm going to update the value to 1965. Okay. And this have a very different effect than line 44. Line 44 is to say, I'm going to look for any row whose key is Pink Floyd. Whenever it's matched the key, I'm going to update the value. When I'm doing iloc, I'm actually just updating one row at a time. Okay. So the line 44 update both rows, and 945 update only the one row that you specify. And finally, you can do deletion. And it's really dumb, but you can do it. You can still use deletion operation. In this particular case, I'm going to look for the entry whose key is stone, and I'm going to delete it from my series. But in most cases, as we mentioned soon, is that we're not going to use this deletion operation. Instead, we're going to use what's called filtering or masks, which is very powerful when you're doing data wrangling. Okay. So I have a few more lines that I'm not going to go over, but I will cover it at the beginning of Thursday's class. So quick reminder, please getting started with homework due. It's due on Friday. So the best way to finish your homework is to solve one problem a day. And then by the time you reach Friday, you will solve all the problems. All right, I think there's actually maybe 2 problems a day. Okay. All right. Any questions? If not, I'm going to start sharing, start streaming.